Derive an expression for the vertical force on the spherical end cap of a horizontal capsule with cross-sectional radius r that is half filled with fluid. So let's draw this figure first. So we have a cylinder, and on each end of the cylinders is a spherical cap. And this figure is filled halfway with fluid. And so we're looking at only one end of this figure. So the figure has radius r for its spherical end caps, and the fluid is pushing horizontally, and vertically against the end cap. And so we need to find f of y. And so we can set up that equation for f of y based off of the basic force equation. Force is equal to mass times acceleration. And so you need to remember that mass is equal to volume times density. So the volume of a sphere is 4/3 pi r cubed. And since we're only looking at half of this, well, first of all, these two end caps create a full sphere. But since we are only looking at one end cap, we're going to multiply this by 1/2 to represent basically half a sphere. We also have to remember that it's filled halfway with fluid. So we're technically looking at half of an end cap filled with fluid halfway. So we times that by another 1/2. And so that is the volume. Now we have to take a look at the density, which is the density of the fluid. So we have density now. And now we need to find a value for acceleration. And since we're talking about the vertical forces, gravity is going to be involved. So A in this case, or acceleration, would be gravity. And so we can multiply these values together, right? Yeah. And so f of y will equal 1/3 pi r cubed times that by density, gravity.